All right, so we're going to take a look at one final example of discrete probability distributions. So it says there are 5 children in one family. Let the random variable x be the number of girls in the family. Let's talk about what p of x represents. P parentheses x represents the probability of having x girls out of 5 children. So again, you think about this, I could have like a boy, a girl, a boy, a boy. There's lots of different possibilities of how we could have all of these individual genders when we have 5 kids. So what is the size of the sample space? This goes back to those permutations, combinations, and multiplication rules at the end of the probability section. So why don't you take a second and think about this. Can you figure out, if I just have 5 kids, how many possible outcomes are there? Well, when you think about it, when I have my first kid, what are the options? I could either have a boy or a girl. So there's 2 options for the first kid. The second kid, boy or a girl. Boy or a girl for the third kid, boy or a girl for the second or fourth kid, and then finally a boy or a girl for the 5th kid. So that is 2 to the 5th power, which is there are 32 different arrangements of the way I could have 5 children. You know, you could have all boys, all girls, so on and so forth. You take a look at this probability distribution, and you can verify that it is in fact, because take a look, you could have 0 girls, 1 girl, 2 girls, 3 girls, 4 girls out of 5 children, or you could have all 5 kids be girls. Now, so the size of the sample space is 32. Let's talk about how we get these numbers right here. How do these fractions come up? Because you actually have the ability to figure this out based off of what we did in the last section. So if we're going to just have, let's take a look at this case right here where we have 2 girls. So what do we have? We're going to have 2 girls. And then if that's the case, then we're going to have 3 boys. But you know that this is not the only way to have this. I might have boy, girl, boy, so on and so forth. So how do we find the number of arrangements possible in this situation? Well, we're going to go back to what we talked about in the last chapter, which is we're going to use factorials with repeats. So let's think about this. How many kids are we having? How many letters do we have right here? There are 5 letters, so we use 5 factorial. But then we need to divide by, open some parentheses, there are repeats here. How many girls are there? There are 2 girls times how many boys are there? There are 3 boys. So this is how we find out how many arrangements of that are possible. And we calculate that by finding 5 factorial times parentheses, divided by parentheses, divide the repeats of the girls times the repeats of the boys. And when I figure that out, I find that there are 10 different arrangements of having 2 girls and 3 boys. Out of how many total possible arrangements are there? There are 32 possible arrangements. This is where we get that number 10 out of 32. Now, let's take a look. Let's figure out and verify that this is in fact a probability distribution. You can add the fractions up, but what I'm going to actually take a look at is I'm going to add the decimals up because this brings up an important point. So 0.0313 plus let's try that again. 0.0313 plus 0.156 plus 0.312 plus 0.312 plus 0.156 plus 0.0313. So when I add these up, they should add up to 1, right? We said for a valid probability distribution, these add up to 1. When I take a look, it adds up to actually 0.9986. That's not 100%, but it's really, really close. And if you add up the fractions, 10 plus 10 is 20, plus 5 is 10, plus 2 is So this is going to add up to 32 over 32. But what's going on over here on this right-hand column? Well, what's happening is some of these values have been rounded, which is why this is still a valid probability distribution, but it adds to really close to 100%, not exactly 100%. But we're still going to say that's valid. Also, take a look. All of these values in here are between 0 and 1. So yes, this is a valid probability distribution. All right, to back up, sorry. This showed us that what procedure would be used to find the numerator of each probability here. It's factorials with repeats. All right, now let's find the mean and standard deviation. I'm going to rely on the technology for this example. We showed you how to do it by hand in the last example, but let's go ahead and let's do this using the Excel spreadsheet. So what do? We're going to put these values 0, 1, 2, 3, 4, and 5. And then on the right-hand side, we are going to type in these. I'm going to do 1 divided by 32. Notice you can actually put fractions into the Excel worksheet, and when you hit enter, it converts it into a fraction for us. 5 out of 32, 10 out of, 10 out of 32, 10 out of 32, and then 5 out of 32, and then 1 out of 32. And it tells us that the mean is 2.5 and the standard deviation is 1.12. So the mean is 2.5 and the standard deviation is 1.12. And this kind of makes sense when you look at the probability distribution over here. When you look at these, what are the most likely outcomes? When you take a look at the most likely outcomes, it's right here. So it makes sense that it's most likely that you have either 2 or 3 kids. This is why the mean is telling us you're going to have about 2.5 kids when you have, or 2.5 girls when you have 5 kids. Now, take a look at the shape of this distribution. Remember, these values start low, increase to 1 or 2 high frequencies, and then symmetrically decrease down. This would look like what type of distribution? This is a normal distribution, right? Okay, so now based off of that, we can start asking some other questions. So let's take a look down here at these other questions. So one of these says, what is the probability of having at least 3 girls? All right, so what does it mean to have at least 3 girls? What does the term at least mean? Well, at least means that number or more, right? So at least 3 girls, that's 3 or 4 or 5. So we're going to find the probability of 3 plus the probability of 4 plus the probability of 5, and then we're going to add those up together. So this is going to be 0.312 plus 0.156 plus 0.0313. And when I add those up, I get 0.4993. Please know that if you do the fractions, take a look. If I do the fractions, 10 plus 5 is 15 plus 1. If I do the fractions, it's going to give me 16 over 32, which is 1/2. The reason we're getting a slight discrepancy here is because those decimals have been rounded. The next question says, what's the probability of having at most 2 girls? This is a challenging one, but again, you need to think about what those words at least and at most mean. At most 2 girls means up to and including. Now, just for sake of doing something different, I'm going to add the fractions this time. So this is the probability of at most 2 girls is no girls, 1 girl, or the probability of having 2 girls. Having 0 girls would be 1 out of 32. Having 1 girl is 5 out of 32. And the probability of having 2 girls is 10 out of 32. When we add fractions, since these all have a common denominator, we add the numbers on top. 1 plus 5 is 6, plus 10 is 16 out of 32, which is 1/2. The last one says, would it be considered unusual to have just 1 girl? What is the probability of having just 1 girl? The probability of having 1 girl is, well, let's take a look right here. I'm actually going to use the percentage right here. So the probability of having 1 girl is 0.156. What would that be as a percent? That's 15.6%. You have to think back to all the way back to chapter 1. What was the first video we talked about? We talked about likely versus unlikely, or unusual versus unusual values. We said that it's unusual if it's less than 5%. This is not less than 5%, so we would say no, this is not unusual. So let's say not unusual.